Hi, I'm John Stallings. I'm a developer at Cambia Health Solutions.
I'm Tim Michael. I'm a developer at Cambia Health Solutions. How many of you out there are developers? Can you raise your hands? How about architects? How about analysts? We're talking to you. We're developers. We're not public speakers. I'm glad to be here. You glad to be here, John?
I'm glad to be here too. Today we want to go over a problem that our team has had with a legacy application that's moved through a lot of different hands over the years, from contractors that are no longer here, business functionality that was created and is now cruft that is not necessarily used in the large monolith that we still have to maintain.
It's a huge critical system that our team was formed about 9 months ago to shepherd into the future effectively. And it's a mission critical system. It's all about accountable health care. It's about value-based programs. Terabytes of data flow through it daily. Lots of money flows through it. But this is what it looks like. So that's a real picture. This isn't something we invented for this show to show a sort of a catastrophe of point-to-point integrations. This is a real system that we're supporting.
And all the different words are just some of the different integrations that we have, from the government to providers and members and their claims data. This is a real healthcare application and sensitive with all the security implications that applies.
And when we inherited and started looking into it, we started realizing that our company has a vision of healthcare, which is fixing it effectively. It's making it more cost-effective, better outcomes, making providers accountable for the outcomes that they're providing to our consumers. And we noticed that this system moving forward was not going to help us reach that vision. So we had to think of something better.
And as we're doing this, we're moving into the cloud instead of maintaining these on-premise applications. So we wanted to think in a new and different way.
I mean, we're a nascent cloud-first organization, so anything we do new is going to be in the cloud. And we looked at this, and we just said, over the years, the cruft, the data that's been jammed into the system, a huge monolithic data model, knotted workflows, the inability to really evolve the system troubled us. Fear and loathing is really what we felt a little bit. But I guess we saw it as an opportunity. How can we reimagine this system?
And when we do have failures in systems, this is ETL based. When the failure does occur, it can cascade, causing other downstream effects. Some of the jobs run 30 hours, so if something fails near the end, you have to start the whole thing over, and all the additional timing issues that entail.
Yeah, forget these bullets. Okay, here's real life right now. We're running 30-hour batch cycle jobs through this system right now, 12 of them. When I look at my inbox, I see that my team has been up 24 hours a day for 10 days trying to run stuff through this system. If this 30-hour batch cycle fails at hour 29, it has to go and start again. And that just was not acceptable to us. So what do we do? How do we reimagine the system?
Yeah, we don't want to take all the problems that we currently have and just move them to another place. That's not going to help anybody. It's not going to make our sleep any better.
Yeah, lift and shift was never an option for this system.
And so what are the different steps that we can take? We have a lot of data, and we don't want to have a huge investment up front of, let's write this whole new solution to replace it and then flip this giant switch one day. That's not an option either. We want to make sure that as we're doing or making these changes, that it's really going to work piece by piece without having to make a huge upfront investment and making a large change.
And by the way, the original title of this talk, this workshop, or this breakout, was Gentle Disruption, which is basically how to migrate your legacy into the cloud gracefully and gradually using things like RDS, Lambdas, and particularly the database migration service from AWS.
Yeah, there's a lot of integrations, as you saw on the slide, with providers and government entities. We don't want to break the existing integrations. We want to provide them something new so they have time to migrate what they're doing, but all the new integrations can be onboarded using newer methods and newer technologies.
And we recognize that there's a bimodal IT model in this world. The batch world is not going away immediately, particularly in our industry. There's a bit of inertia. But we said no more point-to-point integrations. That's just not going to happen anymore. So we decided to created an architecture that bridged the old file, slow motion, IT environment to a sort of a web speed in the cloud. And that's what we're going to be talking about today, how we actually did it.
So these are just kind of the industry buzzwords, but they're important. They're concepts that we can talk about, and everybody generally understands them. We want to be able to make sure that as things happen in an application, that everyone downstream that is interested in those events can consume them quickly and easily without having to wait for a batch to run that may be hours, days, weeks, quarters later.
Make the consumption of data self-service to the consumer, basically, is what we wanted to do.
And since we're also have UIs and other things we have to support, there needs to be a way that those can access data. So we need APIs to make it available in those scenarios.
And we also wanted to decompose this monstrous monolithic data model that over the years had accumulated, and sort of domain-driven design was a fundamental concept in our bridging into the cloud.
It's also important to break it up because the team that we mentioned that's keeping the application running is 6 to 8 pizza team. It's a large number of people. We want to break that down to have 2 pizza teams that are working on a specific domain that they understand well and can iterate on quickly.
We also wanted to design things into the system that would benefit our business. We know our business likes to model things. We know our business likes to experiment. And on our current architecture, when we sit down and talk about adding a new feature, I can see anxiety coming over my team's face. No exaggeration. We wanted to get rid of that. And we wanted to be able to look at new things and say, yeah, try it out. So things like an event sourcing architecture where we can give our business the ability to replay history and experiment, with different profiles when they're modeling things like consumer attribution, which is a core part of our system.
And also, there's other models for event sourcing where they can self-service their needs. If they're a new application, it will help them to be able to onboard. If they need to recover from a database corruption or something else, they can self-service and do that also.
And we also wanted to take advantage of native cloud features, that we can't get on premise, like serverless computing and managed services, RDS and Lambdas and things like that, and DMS. Those are beautiful things. And they allowed us to actually prototype this system very rapidly and then build it very rapidly.
Yeah, we're developers. We want to create features and productive apps that our business needs and will use and not have to focus all the time on the infrastructure. But we do want to use infrastructure as code to stand up everything and share the components that we create with our enterprise.
Yeah, right now our 6-pizza team that's on this, supporting the system is basically keeping the wheels on the bus. And innovation is a small part, a minuscule part of what we do. And we needed to change that.
So this is a picture of where we're heading. This is the emergent architecture that we're working on. This particular picture is not something that this is the solution for all of the monolith. This is a picture of the architecture for each individual domain. So we're going to use this as a cookie cutter for claims or members or provider data or other things that we need to break out into new domains.
Yeah, part of our goal in going forward with this was to build off-the-shelf architectures, off-the-shelf reference implementations. This exists right now, and we built it with the concept that other teams will be able to take this architecture off the shelf and use it for their own, domain needs. So I'll give a little workflow of what happens here is the on-prem still exists. You can see in the upper left. Events happen, say a cut event happens on an Oracle database, a create, update, or delete. Via Direct Connect, which is a physical part of our bridge, we have a 1 gigabyte Direct Connect for our on-premises to AWS. We've set up database migration service. We'll propagate any changes in that Oracle database, any cut event, into an RDS Aurora MySQL cluster. And that cluster, MySQL in RDS Aurora has a great little feature, a built-in stored procedure that allows you to asynchronously invoke a Lambda. Thing of beauty. We wouldn't have done this if that didn't exist.
Yeah,
or it would have looked completely different.
Yeah, it's the linchpin, and it prevents us having to do polling or something else in order to move data from on-prem into the cloud or into events.
So what that allows, every time there's an event, we have triggers in our Aurora database that fire a Lambda, publish to an SNS queue, and then anybody can subscribe to it.
Well, an SNS topic, but that's what supports our pub sub. you can have queues downstream as a subscriber for SNS. So once the data is pushed out into the enterprise, anybody that's interested in a new member being created or new claims data coming in can subscribe. And in order to get that claim or member data, they need to make a API request back to a RESTful API that we have hosted on an EC2 instance. This could change in the future, but for now we're using EC2 to support that. And also, if there's a user interface for updating particular configuration data or something else, that will also use the RESTful API hosted on the EC2 instance.
So let's talk about some of the considerations we had as we were conceiving this. Security was always first. You know, in our industry, HIPAA and PII is always the first consideration. What you're seeing on the screen right now is boilerplate from CMS, the Centers for Medicaid and Medicare. This is their summary of how you comply with HIPAA. The reason this is here is because I've got 3 monitors on my desk. I can't look anywhere without seeing these bullet items. It's always the first thing on my mind. So when we're developing a new architecture, we're always thinking about that first. One technique we like to use is creating a security requirement and architecture matrix. So basically, we list all the security requirements we have that are mandated either by our company, by our state, or by our government, and then we then enumerate those architectural features, in this case it's in AWS, that patently satisfy those requirements.
And as we were developing the architecture, we went through our internal audits. We talked to our InfoSec and AppSec teams who report to our Chief Information Security Officer. And we made sure that this idea that we had created, to make that it would actually work and meet our own internal corporate guidelines for governance.
And these conversations started when this architecture was still just drawn on a napkin, basically. It started early as a recommendation.
But the other interesting thing is the idea for this application, the discovery of the Lambda function, or the discovery of the store procedure that can invoke a Lambda function, that was found about a year ago. But the services we needed with DMS, Lambda, SNS, those were not HIPAA eligible yet from AWS. So make sure when you're thinking about ideas or you find something that you think could be possible, go and check and make sure it's covered by AWS and is HIPAA eligible. And if it's not, contact them. We've worked closely with our solutions architect and others to make sure that features we need get into the pipeline.
There's a little URL down there. That's where they list. As soon as something becomes HIPAA eligible, it's listed on that page, and I check it every morning.
And also, we went through an AWS well-architected review, which has AWS going through our architecture, and then we sat down and went through a 3.5+ hour interview with Amazon, going through a long series of questions.
It's an interrogation. It's not an interview.
An interrogation to find out what our architecture was, and they can go over and report back to us what changes we need to make.
Yeah, I mean, there's 5 pillars that they look at when they're reviewing it. Security is the first one. Reliability, performance efficiency, cost optimization, and operational excellence. And going through this process is highly recommended. It made us, you know, we're in the weeds building a system, and we give it to another team or an outside body to look at, and they take all the SMEs from all over the DMS and from RDS and have them look at our architecture and then give us a report back. And it makes us look, it elevates our view of our system into how it's really going to operate in the real world, as opposed to writing a Python Lambda or doing some IAC code. Okay, public service announcement. And I'm happy to hear that this was in a lot of presentations I saw today. Infrastructure as code. When you're doing something like an architecture like this, do it early. Don't wait down the road to do it. It's a good thing. Your ideas can be made into real things real fast. When did I start prototyping this? May? I started prototyping this in May. I started out on the AWS console. The next day I started doing command lines for my workstation, which is quasi-IAC, but not really. And in retrospect, I didn't really dive into making it really completely an IAC system entirely until July. If I'd done that in, say, May, I would have probably shaved 2 to 4 weeks off our development time. Because you're starting to use your build server and use automation and use IAC very early in the process. Because otherwise, oh, look, I read all these cool things and they all work, but then when you try to integrate them into your build server, you run into a whole host of problems you didn't anticipate around permissions, around policies, around a lot of things.
And it also gives a good target as we're preparing on our development to just share our knowledge and say, this is what we need to do, these are features we need to add, security ideas that we need to make sure are baked in. And it also allows us, since our architecture is going to be reused over and over again, to use the infrastructure code that we've developed on those other domain applications that are going to follow the same pattern.
Yeah, for things like DMS, a lot of what we're talking about today, we were the first people in our company to use these technologies. Like DMS is a good example, the database migration service. And we wanted to build off-the-shelf templates. So we have aspirations to migrate a lot of databases from on-premises into the cloud. And part of what we built in this architecture is a framework for other teams to be able to not go through the pain that we had to go through, trailblazing this, and make it reusable. We're using Ansible. That's our company's choice. So we wrote a lot of, like probably 30 Ansible roles that are reusable by other teams, and possibly we might open source some of them into Ansible Galaxy. Those discussions have happened. We've got to go through legal, but I would love to do that. And the ones for DMS are HIPAA compatible or compliant in that there's no sensitive information ever in our build logs or in any of our IAC scripts, any of our YAML. Any secrets are stored in a secure vault on our build server.
And this is where we start going from the idea, creating our infrastructure, to getting the application and moving it into AWS.
Yeah, part of the database, excuse me, let me get a drink of water here.
So the Schema Conversion Tool is one of the first pieces. It's not something that's deployed into AWS. It's a tool that Amazon provides in order to help you migrate from your on-prem database into AWS. Because you could have DMS does support a lot of source databases and target databases, so you need to be able to determine what your deltas are.
So SCT is a free tool that's packaged with DMS. It's a Java application, you run it on your desktop. I'm not going to give a sales pitch for it, but I love it. It's a really easy to use tool. It's a conversion tool that actually understands heterogeneous DDL conversion. So we're Oracle on one side, we're MySQL on the other side. It will analyze the DDL in your respective schemas and basically convert it. In many cases, it will actually write code for you that converts an incompatibility. It remediates it by writing code. In other cases, it'll just give you recommendations on how to remediate incompatibilities between, in our case, it was Oracle and MySQL.
And it also generates the output that is used for data migration service in order to replicate the data from on-prem into Oracle.
When we're building things in DMS like replication tasks, this tool can output JSON that you feed into that to actually configure what tables you want converted, what conversions you want made to that data. So next, we have to move the data. You can use the database migration service can do bulk loads, which is what we initially did, is just moving, and an idea of how much cruft was in our original legacy source database. That's a 2 terabyte database. When we did a bulk load of the data just we needed to handle like consumer attribution and provider delegation, it was 20 gigabytes. The rest of that 1.8 terabytes was cruft.
And this is part of breaking up our huge monolithic domain into multiple domains, because the tables that we did replicate are for 2 separate domains. We have member data, and we also have the attribution data that we need to move over. But those are treated as two completely different applications.
Yeah, so one of the cores to our bridging strategy was the idea to be able to shadow that selected data, that 20 gigabytes, whenever the source data changed on our on-prem database, it needed to be replicated into our cloud repository, a new one.
So
DMS components, I'll just go through the quickly. Replication subnet groups allow you to, it's a security feature, and for us it's also a feature to allow those components in the VPC where the DMS exists to be able to communicate through our direct connect.
And in KMS, when you're configuring it, make sure you don't use the default that's provided per account in AWS. You want to be able to control your key rotation. You want to make sure you're not using the same key for every type of the same resource, so you don't have a default key for all of your RDS instances or all of your Lambda functions.
Yeah, for a lot of AWS services, when you use the console to create something, it's doing a lot of things under the hood for you. One of the things it's creating, like it would have created a AWS DMS key. It's not a manageable key. It's not a secure key. You can't rotate it. Don't use it. Because everything is secure in flight and at rest, our database connections to our source database on premises and our target database in the cloud need to be secured via SSL.
And from our applications to our database. Also encrypted.
This is an area on the target side, it's really easy. Amazon publishes a PEM file that you can use as the SSL cert. On the Oracle side, a little more problematic. They have their own proprietary way. It's like a 30-step process. If you look in the AWS documentation, do it with 2 sets of eyes. It took us 2 weeks to get it to work. Also note that it's a binary as opposed to a PEM, and binaries can get corrupted.
And so when you flip the switch and start replicating the data, we're doing an initial full load, and over time, because we're consistently streaming the data, we don't want to, as we said, cut off the on-prem integrations. We want to give them a time frame to move over from on-prem into the cloud. So we're using change data capture also.
Yeah, I mean that's one of the key features, and this the whole replication process is highly configurable. There's like 50 parameters in a replication task that you can configure for how it handles if a cut operation fails on the target side, or if the source goes away, or how many threads to use, or how many tables to update concurrently. We're still playing with the combinations and permutations to tune it. Fortunately, right now, we're only doing 20 gigabyte loads at a time. In the future, when we're doing terabyte loads, we'll spend a lot more time tuning it. Right now, the 20 gig takes about a little less than 2 hours to get bulk loaded.
And it's been pretty fast and pretty performant. Now, the next step after data migration service is to invoke the Lambda, because we're not just moving data into the cloud, we're creating a whole new way for our downstream consumers of data to integrate with it. This is a change for our organization. We're very used to ETLs, files being moved from one place to another, but we would provide the ability for data to move faster. A member updates something in the portal, that change can be propagated very quickly to anybody that's interested. If it's a new business idea, they want to spin it up, they just subscribe. There's no new file integration. They don't have to have direct access to a database, and you can control things much more granularly. And this is the magic that we found in the Aurora MySQL documentation. This is the stored procedure that makes it possible for our solution. Without this, we would be polling the database. We would not be able to push data as quickly. There would be some more of a delay. And we'd have to write more code to do all of that. So far up to this point, we've just been tying together pieces that AWS provides in their managed services. So in the stored procedure, the first parameter is the Amazon ARN, or the Amazon resource name. This is a unique identifier that is used for the majority of Amazon's infrastructure. So every Lambda function has a unique identifier as an ARN, SNS topics, queues. The Aurora cluster has its own ARN. The second parameter is the event data that we're going to be publishing and pushing out to the rest of our enterprise. The next step is when we push it, we're pushing it into an SNS topic. So this is the piece that drives pub sub, where we have a single message, and you can have up to, I believe, 10 million subscribers on that. You can use any of the technologies that Amazon makes available as a subscriber. They have HTTP, HTTPS, email, SMS. You can push directly into a Lambda function to do some work. But we have SQS pictured here because we think it's something that's valuable for event sourcing. It adds a disconnect between events coming in and the applications downstream that are using it. It's a slight piece of decoupling. And this is kind of a pseudo call stack of everything that's occurring from our ownership as a publication application, from the on-premise database change, which any create, update, or delete. There's no additional application logic added here. Just adjust your logging on the on-prem database depending on what type it is, for what DMS needs, DMS will replicate that data for you into Aurora MySQL. There we've written triggers for the create, update, and delete events.
Yeah, this whole stack here is executed by two stored procedures and one Lambda. Less than 100 lines of code. So simplicity was really a key to what we were doing.
Yeah, we wrote a lot more code for our infrastructure as code, standing all this up so that we could share it. This is very minimal. The Lambda is literally 5 lines of code. It says, I have an event, and I'm going to send it off to the appropriate SNS topic.
Yeah, I wrote the stored procedures in the Lambda in one day.
Yeah, it's very quick. So once you've invoked the Lambda, the message is pushed into SNS, and then it's the responsibility of all the subscribing apps from that point on. But we also want to make sure that all the downstream subscribers get all of their events. We don't want them to have data inconsistencies and have concerns. So if the Lambda invocation fails in the store procedure, the database commit or the database transaction will fail. If the Lambda fails to publish the message into SNS, with async functions, there's a slight retry. But if it does ultimately fail, we have a dead letter queue that the Lambda will push the event into. At that point, if we have CloudWatch configured, and that's a monitoring and logging service in AWS, and if any messages at all make it into SQS, then we send out an alarm. In this case, we email our NOC, we get calls, and we have to go and fix whatever is causing the problem with Lambda pushing the events into SNS. Once that's fixed and all of the new events are streaming through, we still have to figure out what to do with the SQS events. So we need to take those events and replay them into SNS so that all the downstream subscribers are able to receive the event. And because of that, you also want to make sure that when your downstream applications are written, that they can handle out-of-order events. Because once the fix occurs and the events are streaming through again, the old events or the events that failed are being replayed, and they won't be arriving in any particular order.
You really want me to say idempotent, don't you, John?
Yeah, sure.
The client should be idempotent. I mean, out of order or anything like that, they should be able to tolerant of a repeat.
Yeah, and there's a lot of other scenarios for being able to replay events that we'll go over in a little bit, which brings us to our required presentation quote.
The required Martin Fowler quote. And here's a funny story. Yesterday in the speakers' preparation lounge, we were doing prep work and getting coached and all that. You can see how good the coaching was. The first other speaker I talked to, we mentioned we were going to be quoting Martin Fowler, and he goes, yeah, so am I.
Yeah, we had a competition between event sourcing and CQRS for our quote.
No CQRS.
So here, we really want to emphasize that with event sourcing, you're going in and you're persisting an event into the database as they're occurring. Those events can then be replayed back into the application. So if there's a bug that occurs, you can go and replay the event and reprocess it once you fix the bug. If you have an entirely new subscriber to onboard, you don't have to create a side load for the file or something else into that application. You can request that the exact same flow of data that the events be replayed, and then the application will load those events.
And it's supporting a microservice architecture because you can denormalize your microservices, meaning they have their own repositories with their own copies of claims data or member data, and they can hydrate those through this event sourcing mechanism, and then our pub-sub architecture through subscription keeps all those denormalized repositories synchronized.
Yeah, and I have to apologize since I'm not a normal presenter. In our triggers that are calling the wrapper store procedure that invokes the Lambda to downstream for the event, that is, we also persist an event that has the change data capture data for that particular state that we're triggering the event for.
It's a time variant database for a lot of the more important attributes.
And this is what our events look like. The very basic of the event identifier, a date timestamp of when the event occurred, and an action. In our case, it's create, update, and delete because that's the type of triggers that we have. And that can change in the future as we create the events based on application logic. But one of the things you won't see here is what is the event? Is it a member event? Is it a customer event? And that's driven based on the SNS topic.
And I'd also note the ID is a real UUID. It's a RFC 4122 version 2. It's important that because of the nature of the system, the time variance, the way this data moves all over the place, that ID is unique across space and time. I love saying that.
And we also want to note that this event is based on a domain. So it is a member event or claims event. It's not claim table 1, claim table 2 events. We want to break it down into a domain because eventually the technology underneath this could change. It could move to a document database instead of a relational database. There could be triggered in any different way that's not directly related to a table. But the final piece is, where was the data that we actually have for the event? We don't actually publish that with the event because we want it to be able to go anywhere in the enterprise where people care about the changes. In order to get the event data, you have to make a RESTful API call back to the API hosted on EC2 instance, and then the body of all the change data capture data is returned. Also, the RESTful API supports querying for UIs, and it's used for requesting that events be replayed back to a particular application or to the source SNS topic if it needs to be replayed to everyone. The body of the messages that are returned is also controlled based on the EC2 instance because there are many different applications that we integrate with. Some of them should have access to, say, a full tax identification number. Others, maybe it's just the last 4. Some of them may just need to have first name, last name. We want to use the principle of least privilege when creating our responses from the API calls so that we have an auditability and the ability to control what different teams or what different applications have access to. Some of them are internal, some of them are external. But what if there's a bug or any other issues for being able to replay the event? We kind of alluded to why we have SQS depicted as the subscriber to our pub sub topic. If we're replaying an event for a bug, if we replay it to the topic, all the subscribers will receive that event a second time. There could be 50, 100, 300. And that additional processing can add up in costs over time. There's also extra noise and logging, and if somebody else is trying to troubleshoot, they have to go through the logs and find out if things were replayed again. So we recommend using SQS. Here we're depicting bypassing the initial publication or the initial subscription going through SNS to the queue. Instead, we're using the RESTful API to replay one or more events, bypassing the topic into the team's subscription queue, kind of giving it that decoupling that we talked about.
This is how we wanted to do it. Unfortunately, this isn't supported right now in the AWS service world.
No.
So
we're kind of taking advantage of our chance to be up here to hope all of you, if you find this ability interesting, to go and request your technical account manager, your solutions architect.
They're called PFRs, product feature requests.
And please about this because
We're not afraid of asking for them ever.
Yeah, because the solution a year ago wasn't possible. It was based on conversations we had with our solutions architect that the technologies that we needed became HIPAA eligible so that we could do this and make things much simpler for us, where we're using their tested infrastructure in order to create the solution.
Can you believe it took us this long? Go to the next slide. It took us this long to mention Rube Goldberg. He was supposed to be peppered throughout this whole thing. But you can do it using, current Amazon architecture, but you have to do it at a little Rube. There's more moving pieces, there's more complexity.
Yeah, but since we did this with infrastructure as code, it's written. It's parameterized, and we can reuse it over and over again.
So yeah, we have to create the reference implementation, and then we just put it on the shelf and other teams can use it.
Yeah, the first implementation for this, we use it for doing load testing on our API. So if we publish 1 million events, how does the API handle that? So again, here we're bypassing the SQS topic. We are monitoring that topic, just like we did with the dead letter queue earlier. If any messages come in, CloudWatch will be monitoring it. In this case, instead of sending out an email to the NOC telling us to go fix something, it will publish an event into SNS. Lambda can subscribe to SNS, so Lambda is invoked, and it starts pulling the queue to process the data. You can either forward that on, or you can process it there and continue the cycle until the queue is drained.
And we as the publishers don't know that's happening. It's just sort of transparent to us entirely.
Yeah, all of this is downstream. If I'm requesting events to be replayed because there was a bug that I had to go in and fix, and we've deployed the fix, and all the new events coming in are succeeding, I can make a request to replay any of the events that had failed previously, and I don't have to tell the publishing team about it at all. I don't have to embarrass myself saying, sorry, I broke something. Can you come help me out and replay the events? So this really gives the ability for all the downstream applications to be self-service.
I mean, we're a full stack team. We want other teams to be full stack teams as well so they can be independent.
Yeah, because as we break up the monolith and move the additional pieces, which are very basic member and claims data, we're going to be building on top of that with new applications. And we're going to be not just the publishers, but also the subscribers to these applications and microservices that we're creating. And here we go. So now that we have these services deployed into AWS and other teams are able to use them and process data downstream, where do we go from here?
Well, there's no more point-to-point integrations. That's one beautiful thing. Our new integrations consume events, we're eating our own dog food, so to speak, in that to build on what we have to go forward, we're using what we've already built.
And the interfaces are defined. We have the events that are being published, and we have our RESTful API. And when we were creating our domain-specific applications, Swagger or Open API spec were very useful in being able to define what the API looks like without having to do any upfront development and have a conversation around, well, is this what the domain looks like, or is it like this? And make some changes and alter things as part of the discussion with other teams. It also allows us to create smaller teams as we move things into the cloud and make them independent from, we need your ETL application. They can just say, hey, we need an API key to authenticate for the API and subscribe to the events that are being published.
Yeah, and it's clear, I mean, as Churchill said in 1942, we're not talking about the end here. We're not talking about the beginning of the end. We're talking about maybe the end of the beginning. That's the point we've reached right now.
And the other cool thing is, if the business has a new idea, say if event A and event B happen in the enterprise, if we do C, does that add value? Does that create something very useful for our consumers? If in 6 months we find out, hey, this was a great idea, we tried a couple different features, it didn't work, you can go and take that microservice and just delete it. You don't have to let it sit there and rot away in the body of a monolith. Because a lot of the time that we spend with developers trying to add new features to the large on-premise application is spent as archaeologists, not as developers, trying to go and figure out what is actually going on in this huge application.
And there's still a lot of archaeology in our future because, like I said, this is the end of the beginning. This is part of a multi-year journey to move everything you saw on that first architecture slide, or 99% of it, into the cloud. And note that, like, Netflix took 6 years to move all their streaming operations into the cloud. So we're not Netflix, but we understand it takes a long time.
And we learned a few things along the way.
Yeah, I spent a lot of time prototyping in a sandbox. Always make sure you have a sandbox environment where you can just let a developer go in there unfettered in an AWS sandbox and just build things. I stood up DMS, I stood up RDS clusters, I tore them down, I stood them up. And this whole architecture got validated in various POCs in 2 weeks. And then we actually started building it. As I said earlier, start your IAC development early. This is another case of eat your own dog food. Start working on your build servers and your CI/CD, your continuous integration, continuous delivery, even while you're still developing. Don't wait offload that to the end of your process. You'll save enormous amounts of time. And
also, when you're creating your infrastructure, make sure you pay attention to the IAM roles or policies you're creating. Reduce the privileges you have to the bare minimum, and as you go through the different steps, you can add additional access rights or permissions to different resources. The errors that come out of Amazon's SDK are very helpful. They'll tell you exactly what you need to change, and again, it makes sure that you're using the principle of least privilege as you're going through and developing your application. Because security is, we're in healthcare, and security is of utmost importance.
And start your SSL configuration, bring in SMEs, bring in subject matter experts early on. We were going on-prem, we just sort of full duplex on-prem to cloud and back for DMS. And there's a lot of little nuances there when you're setting up SSL connections to Oracle. Probably the biggest delay in our whole process was just getting all the bugs kinks ironed out in that.
And for a lot of this, since we're a very small team, where it's really a one-pizza team developing this solution, we did pairing often because we need to be able to support each other if one of us is gone on vacation or if we need to work on a different technology based on time constraints. So as a group, we're constantly doing pair development. We're checking each other's code and making sure we all understand the different technologies.
You forgot that colon, John.
Yes.
It needs to be 4 spaces, not 2 spaces.
I missed my curly brackets. It's also, it's also really handy because we're working in different technologies. We don't just write an application code and then throw it over the wall. We write the infrastructure as code that stands up the infrastructure for our application. We write the code for our APIs, the store procedures, the SQL. We also go through and write the automated testing, so unit tests and integration tests for our application. And we have to automate all this through our build server. So those pieces are also taken care of and shared across the team. We don't have any individual responsibilities.
And that's why we decided to do pair presentation here today.
Yes.
It's our first stab at it.
And always, because again, the solution wasn't possible a year ago when the idea came into our head, engage your AWS solutions architect, your TAM, create product feature requests, because the features you need, there's a lot more of them out there in AWS than what we can currently use. So make sure what you find important, what you will find useful, that you go out and ask for it. And all of us working in healthcare will benefit from it because we'll have more tools to provide the solutions and applications that we need to drive our industry forward.
And engage your solutions architect, your AWS solutions architect, and TAM on a regular basis. Not when you just have a question or a problem, but here's what we're planning on doing, just so they know what your roadmap is. So then when a new feature, a new product, a new service comes up, they'll push it to you. You don't have to find out about it, in a press release. Or you can find out about it beforehand, in a confidentiality way. So engage them. We did. Kirk, thank you very much.
And for those watching this online, here are a few references that you can download with the slides. And with that, thank you for coming and listening to us.
Thank you.